I want to do some truss analysis. It's funny, this is the second time I'm doing this video because the first time I did it, my microphone wasn't hooked. So let's try again. And that's why I have all these on the board. So we have this truss right here, and we want to find out the member in H, I, C, H, and CD. One of the first things you do is take a look at the truss first, and is find out what's the best way for you to find those member. Is it, should I use method of joints, or should I use method of section? And when you look at this, method of section make more sense. So draw the free body diagram, make the cut where you want, like we want to make a cut between H and C, as we show right here. And once you make your cut, and then where you make the cut, replace those member, between those member and the next joint, replace them with a force, like I have here. And the big thing about truss like this is the geometry. Figure out your angle of your forces, nothing to it. When we look at this truss is about 45, it's 45 by 15. So 45 divided by 15 is 1, 2, 3. So we know this angle is going to be 1, 2, 3. And then because now you know the pitch of this line, so where you make your cut, okay, I'm going to have 18, and 18 divided by 3, that will give me 6. So if I have a 6 here, then I have 6 going this way, and 9 going this way. So pitch of this line is going to become 2 and 3, and you can figure it out. That's the most important thing. Once you figure those out. As far as the direction of your force, you can guess at it. Make an educated guess, or just guess at it. If you're wrong, your number comes out negative, and you can make the correction. So this is being compression both, and this one will be in tension. And all the dimension is given. Okay, so let's get to work. First, what I want to do is figure out what if I take a moment about point C right here. If I take a moment about point C, then I'm going to eliminate this force. I'm going to eliminate this force. All I have left is over this one, which is both has a vertical component and has a horizontal component. So, okay, let's do summation moment about point C. Summation moment about point C equals 0. Let's go counterclockwise. This positive. So I'm going to have a 1 and 3. So it's going to be 1 FHI square root of 1, 1 over square root of 10. All right, so that's the vertical component of that force. And that's going to be positive. It's going to be multiplied by 9. And the horizontal component of this force, it's going to be 3 on 10. So it's going to be FHI, all right, 3 on square root of 10 times 6. Great. Okay, now this is no good because they're going to the same point. Then I have this one, it's going to be 6 times 9, and that's going to be negative, minus 6 times 9. The next one is going to be minus 6 times 18, minus 6 times 18, and the next force is a 3 kips times 27. Minus 3 times 27, we got ourselves a 0, equals 0. Okay, therefore, FHI comes out to, what do I have? 28.5. 28.5 kips, and that's tension, because we said there was tension, and we were right. Okay, here's the next thing. You figure this out. You look at your member here. You can do two things. You can use a summation Fy, the next step, because I already know this. If I use summation Fy, this has a y component, this has a y component plus this. That's one way. There's an easy way also to do that. What if I can take a moment about point F? Is eliminate this, all I have is this. Both result should give you the same thing. All right, I do one, you do the other one. So let's go ahead and say, okay, we can go ahead and to calculate FCH, we can do summation Fy is equal 0, going up as a positive, and that's going to be that's 1 and 3, so it's going to be came out 28. FHI came out 28, so it's going to be 28 0.5 times 1 on square root of 10. That's the vertical component of it, that's a positive. And then plus this one is the FCH. FCH, and the vertical component of it, it's going to be 2 on 13, 2 on square root of 13. And then you have the other load, which is a minus 6 minus 6 minus 3. Minus 6 minus 6 minus 3 is equal 0. Figure that out. I haven't done it, but I bet you it comes out the same. And now the other way we can take a moment about point F. Say summation moment about point F gonna come out 0, going counterclockwise is positive. All right, and point F. I don't have to worry about this. I don't have to worry about this. All I have to worry about the vertical component of this force. Horizontal components are the same line. So the vertical component of this force is going to be 2 on square root of 13, which is the FCH. And that's going to be multiplied by 999.27. And that's going to be negative based on our sign convention. Then we're taking a point about F, so it's going to be 6 times 18 plus 6 times 18 plus 6 times 9 equals 0. Do I have that? 6 times 9, 6 times 18 minus that, 2 square root of 13 times 27 comes out to FCH equal 10.8. Okay, so FCH is equal 10.8 kips. What do I say it was? It was compression. Yeah, compression. Perfect. So that came out okay. See if this one comes out the same. And so now we have that. So we calculate this first, we calculate this first, we got this one. There's two ways again we can do this. We can do summation f of x, or we can do summation f of y. Summation f of x, it's going to involve this, this, and good luck to you. So let's do it both ways. So that's a FCD. We can do summation f of x is equal 0. You do that. I do the other way. I think there's an easier way. What if we take a moment about point H, okay? It's going to eliminate this. It's going to eliminate this. So all I have is the FCD. So it's going to be a summation moment about point H is equal 0. Let's go counterclockwise positive. So I have that force. It's going to go positive. So it's going to be FCD times 6. And then this is nothing. So it's going to be 6 times 9 minus 6 times 9 and minus point H minus 3 times 18. Equals 0. So that's going to be FCD equal 18 kips. What would we say? Compression. Okay. So this is how you solve this. Look at your truss and figure it out. And whatever easiest for you, that's the best way to do it. Don't go away. We got one more problem. If this stress is what are we looking for? We're looking for classifying this stress whether it's statically determined or statically indeterminate. So if we look at this and count all the joints, count all the number, and we had this formula called, if you remember, let me get the PowerPoint up here, if I find it. We want to know if it's B plus R minus 2J, which that kind of come out to. So we're going to have that. If you count all the members, we have 1, 2, 3, 9 members. 1, 2, 3, 4, 5, 6. So B is equal 9. And then we have reaction. Ooh, we got 4 reactions. So R is equal 4. And 1, 2, 3, 4, 5, 6. Your joint is equal 6. All right. So if we use this formula, it's going to be 9 plus 4 minus, 9 plus 4. So it's going to 1, right? So that comes out to 1. And the stress is indeterminate by the first degree. That's it.